Basically, here is my power switch for my inverter. Here, click on. There's the microwave turning on. And this will give me my indication of my voltage coming out, the current going out in amperage, the wattage, frequency, all that type of stuff. This is really nice. This little device up here tells me everything. This is the shunt meter. This tells me everything that's going in and out of that battery. Tells me you put in how many current amps you have, and it will calculate how many amps you have left by how many amps are going through that shunt. That also records how much is coming in and out. Currently we're in a discharge state of 20 amps. What the hell are we using 20 amps for? What is using 19 amps? The solar's disconnected. Let's shut off the inverter because I know that has some parasitic draw. Oh my gosh, look at that parasitic draw. But what should not have 20 amps worth of draw? Because if I click that on, yeah, there's something running on 24 volts that's taking 200 watts. Let's go look. I found it. It's the refrigerator. The refrigerator was set to AC. Let's see, so let's turn it to LP gas. Since the gas thing's turned off, it'll still try to ignite and everything. But let's see what our current is now. Okay, that's a much more reasonable parasitic draw of 1.8 amps. I know it sounds like a lot, but when you got 400 amps, it's, you know, you don't leave it on all the time, that's for sure. So I've only got 1.8 watts outputting on the inverter. So that's what's nice, because you can actually take a look at this and go, wait a minute, what's connected, what's working, what's drawing. And with the schematic, you can go around and shut things down. And let's see, so with the inverter shut off, I still have 0.88 amps of draw. Now generally that'll be from the little lights here, the CO2 detector, the carbon monoxide detector, this charger. But what I can do, I will go back here and disconnect the bus, disconnect the system. And you'll hear everything do its dying gasp. And let's see, the battery monitor's still on, so it'll pull a little bit. Oh, or nothing. There you go. Zeroed out. Nothing leaving, nothing coming in. Let's flip on the solar charger just for giggles. Go down here. Oh yeah, it's part of disconnected too, so stand by. All right, reconnected the 12-volt bus and the solar. Looks like even with dirty panels, and honestly, our voltage is pretty high, so we won't be transferring that much current. I'll drain it down, leave some shit on, and we'll see where it goes. Okie dokie, I'm using the air conditioner to pull the battery down. I'm about 67%, pulling 103 amps out of the battery, and 1.2 kilowatts is coming out of the inverter. That inverter says it's 3,000, but I've overloaded it at about 2,500 with just inductive heaters, so I don't know. Energy again, so who knows. All right, so we're gonna shut off the air conditioning. Shut off the air conditioning. We have 1.2 amps still draw from the inverter. Shut off the inverter. We have 0.4 amps of parasitic draw. So now we're at noon right now, and we're about as high as the sun will get. Turn on the switch, see what happens. So now our solar converter is starting to charge. It is interesting, it's a slow ramp up, but here we go. It looks like we've topped out at 2.2, 22.7 amps. Let's see, so what is 22.7 amps times 13.3? Let's find out. Stand by. So I did the math. This 13 times 22 approximately is 301 watts, which is half of what my panel should be rated at. Why is that? I know there's some inefficiency. I know normally they're about 80 to 70% of what they rated. The sun, it's also July. It's noon 30, and the sun is approximately 20 to 25 degrees from dead perpendicular to the panels, because the roof kind of slopes down a little bit, and I'm pointing it that way, and the sun is that way. So there's a 20-25 degree difference from perpendicular the sun rays to the antenna. So I know that, or panels, I know that affects it. That much? Half? I don't know. Maybe it's the controller. Maybe it's my Wanderer cheap little controller that has inefficiencies. It's a 30 amp, so it should at least be able to put up that much. I don't know. What do you think? What is my solution to get more out of there? So I got home about an hour ago. We're in Madeira. I've got lots of solar, so we were able to get the batteries up to 100%. We rode to Bald Mountain. We trailered to Bald Mountain. We rode Bald Mountain. I rode a dirt bike. Most everybody else was in four wheels, side-by-sides, etc. Abel was in his Toyota. And his Toyota didn't break this time. Imagine that. Anywho, his tow rig did, but that's another story. So it was nice and hot. We got back about 4:15, I think it was, and it's like 4:30 now. So I came home to the camper in the middle of an open lot. I'll show you that in a minute. Turned on the air conditioner, ran it almost full blast. It's the middle fan speed. So this is how it's been going for the last hour and 15 minutes. It's very comfortable in here right now. It is 103 outside. A little breeze, so it's not horrible, but still, I don't have any idea what the temperature is inside. That would be a really great number to show y'all, but here is the everything that's going on. All right, here's the control panels I showed you earlier. This is the battery we're currently using. We're at 13 volts. We're using 103 amps. Geez, can you see that? This is the battery box is at 116 degrees. We're at 73%. Down here, the inverter is producing 1.3 gigawatts, 11 amps of current at 120 volts, 60 hertz, going into the air conditioner. This is really nice because it tells me I've got about 73% left, an hour and 15 minutes. That works out about right. So this is 103 amps. It's pulling hard. Let's see if the thing is, the inverter is on. Air conditioner's nice and cold. It honestly took a while. It took a while to cool off the cab because everything was hot in here. But let's see how the battery box is doing. Oh my God, it's hot out here. Okay. So the fan is on, and the inverter fan is on. Let's see, are these? Worried about these getting hot. That's warm. I don't like it that warm, but I can hold my hand on this one. Can't really hold my hand on that one. So I don't know. I like to know what temperature it is. I like to have some input. Should that be cold? I mean, there is 105 amps going through this fuse block. This is the battery monitor, the shunt. So through this cable, it gives it to this little guy that will send information to my phone into that display. It tells how much current is coming out of the system. There's the other 2 batteries, or 3 batteries down there. And yeah, that's it. It's actually working pretty good. I'm gonna let it run while I go swimming. Peace. Happy trails. Okay, it's been a little over 2 hours and we're at 50% capacity on the inverter. The inverter fan is running and everything doesn't look like it's melting in there yet. So let's see what it is inside. Oh my gosh, it's got to be 20 degrees in here. No, actually I really don't have any idea what temperature it is because I don't have a temperature gauge. So let's see. Oh, compressor kicked on. So I got about 2 hours with this capacity. There's 1.2 kilowatts, 118 volts. Everything's going good. I'm going to do it to the point of failure. I have an alarm set for an hour and a half. It should give us 30 minutes. And that's what happens when everything goes off. I'm not sure what's going to happen to the air conditioner when it suddenly shuts off, when the batteries turn off, but we'll find out. All right, 4 hours later, and we are still running air conditioning. I am down to 7%, 6%. Let's take a look. Ooh, it's in the red. Down to 7%. Ooh, 130 amps. That was a 130 amp surge, while the battery still has 7% capacity. It's been running, let's see, I started at 4:15. It is currently, I have no idea, I'm gonna say 8:15. The temperature of the battery compartment is 108, so still warm in there. Still pulling 1.5 kilowatts, or 1.15 kilowatts, 130 amps, 7%. All right, we're gonna see what happens when it fails. We're gonna let it just go all the way till it, I don't know, hopefully till the BMS kicks in and stops the batteries. I don't remember what voltage that is. Let me look it up real quick. So it looks like the over discharge voltage protection is at 9.2 volts. We're nowhere close to 9.2 volts. We're still at 12 and a half. So this device calculates the amount of current leaving the battery bank. The way it does that is you tell it how much current it has, 400 amps, and you tell it when it's reached its maximum charge. So when it's reached its maximum charge, it has the high point, and it knows it has 400 amps from there to pull from. So at 5%, we have pulled 1,300 watts. Upper right, we pulled 1,300 watts. I don't know. I don't know why that. I think it has 1,800 watt capacity. We're still at 5%, but we're still 12.5 volts. So we're a ways away from the 9.2 over discharge voltage protection. I don't know when the batteries will kick out. I don't know. We're at 4 hours and 15 minutes of running the air conditioner right now. It's cooled off significantly because it's 8:30, but we'll see. So I never ran into the point of failure. I figure, what's the point? It worked great, and I don't want to actually damage anything by heavy spikes. Yeah, so you can do this too. There's lots of resources out there for help you out. My buddy Eric at That'll Do Engineering edited this for me, so give him a like and follow. He'll appreciate it. If you like the video, give me a like and follow, and we'll try to do more of these. Anyway, that's it for now. From Tom and Karen's Curious Compass,